Hello and welcome. In this tutorial, we're going to create an RGB LED Color Mixer. Basically, that's a device that can create any color imaginable on that LED using these potentiometers as knobs, which can sort of turn the level of red, green, and blue. So we are going to accomplish that by using the PWM feature, so analog write on these pins on the RGB, and then controlling that analog write through 3 potentiometers. So I suppose we can look at that code that we previously had from the series of blinking red, green, blue, red, green, blue, red, green, blue, and see what we can do to just analog write a particular value onto some of these red, green, and blue aspects of that LED. So let's start by adding 3 inputs because we're going to have them pin mode. We need 3 analog pins. I'm going to go from A345. So A3, comma, input. A3, A4, A5. Then we're going to have something like 3 values. So int red, or potentiometer for red. I think we can just say red level. Red level. I like it. Int red level. Red, blue, green. So right here where we have these delays can go away. Essentially we're gonna get rid of all of this and make that into analog, right? In fact, I would be faster retyping this in some respect. So first off, we, instead of high or low, we now have a range 0 to 255. What is interesting and strange is that analog read goes from 0 to 1023, whereas analog write goes from 0 to 255. So just for interest's sake, I'm going to try writing 100 to the green one. And there you have it. So we can now mix a bit of blue, 100. So that's green and blue. And now if we make it barely green, I can just put like 5, a tiny amount of green. Yeah, so it's mostly blue. So this stuff works. So what I would like to do right now is to set red, green, and blue levels. So we're going to read them off of the 3 pins A3, A4, A5. So we can simply say red level equals to analog read A3, and then do the same for green and blue. So I don't even think I'm going to need to serial print here, but we're going to see. I think I will, though. I think I will, because I'll show you right now, because 255 has to be the limit, and I need to see green level. So we're going to write these 3 values on it, and then I'm going to control, I might just control green because it's the most visible of all the 3 colors. Our eyes are most sensitive to it. So I'm going to go serial.begin 9600. Very neat. And here we're going to go serial.print and we're gonna print red level. So we're gonna go ahead and do this. And yeah, very interesting. I expected it to be higher. So we can now write in red level. Or wait, was I gonna do green? Yeah. We can now write red, blue, red, RGB, green. Okay, for argument's sake, I'm just gonna make the other two to 0, and I'm just gonna control the green LED. So right now we should see a little bit of green, and we should know exactly how much green we are seeing. We are seeing about 70, 80 points. So our goal is going to be to make those values go from 0 to roughly 255. So I'm gonna fix and set up that potentiometer now. Just for the green, we're gonna check out that everything's okay. I think green is on... So green level is gonna be A5. Rightio. So this, let me zoom you guys in. So this right here is going to be the green knob. So I'm gonna connect that to A5. Oops, I think it should be there. And bang, see how much brighter? Inconsistent, max. So now I'm gonna put this potentiometer in. All I need is any one of the pins on the other side connected. And it looks like the potentiometer is down to 0. But look at this, check this out. So you see how it ends here? That means we got to 255 enough. So that's what we need to work on. So right now, that live reading is gonna be super useful. 514. 514, that 514 is a fair bit. 255, and does it go all the way to 0? Yeah, 0 to 514. 514 is more than 2 times 255. So now I'm gonna try to make this dial, turn it from 0 to 255. And I'm gonna write in green level equals to int green level over, and to get it, see, int turns it into an integer. To get it to 2.1, I believe right now when we put this guy in, we should top out at about 250, which will be perfect. Let's see it. 244. Yeah. Let's see if we can do a little bit better. Divided by 2.08. Yeah. 2.09. I think, I don't know why I'm going to such detail. 245, it doesn't matter. 245 will do. And we can do the same for the other pins, because even though these potentiometers may just put those levels at slightly different values, we know the potentiometers are roughly the same. So we're going to basically... Oh, by the way, merge. Let me show you the code that I was working on, and let me show you what you were looking at, because this is what I did. I wrote int of green level divided by 2.09, and then we saw the values. And the values are right here. They are 245. So when I crank this to the max, it's 245, and when I drop it down, it goes to 0. And if you can look at the LED and the numbers, you're going to see that those numbers indicate the LED brightness, which basically gets our LED to the full range. And now I'm going to copy the same line of code, and I'm going to make it for the red, blue, red, blue. And I'm going to go back into the circuit, and I'm going to build the other potentiometers. Should only take a minute, really. There we go. Let's see if we can keep the gap consistent. Dun, dun, dun. Get some of these. It doesn't really... We'll get them all into the bottom leg, because that way we're turning the knob always in the same direction. 3 resistors going into this one. And now there we are. Can you see everything? Yes. So now that I have the circuit, I'm going to go back into the program, and I'm going to upload this, and we're going to see if all the lights work well. So I'm going to crank everything down to 0. So I'm going to try the... Aha! Not complying. So this one isn't working, but that one. So, what's wrong? What's wrong? What's wrong? Aha, we are not writing the level here. We're not writing to the red level, and we're not writing the blue one to the blue level. Okay. So, let's check this out again. Ooh, looks like blue one's in the middle. Crank it all the way. Doesn't go off. Perfect. So we got blue good. We got red. Cranks all the way. And here we go. That's white. Turn them all on. Want to make a purple color? I guess we need to take out a bit of the green. Where's the green? Right there. There you go. You got purple. If it's too bright, you can turn these both down and make a more peaceful purple. I can turn these lights off so you can see the colors a bit nicer. 1 second. Whoosh. There you go. Purple. Bit of green already changes everything. I'm gonna turn everything to 0. We're back to white. I think the zeros are this way. Ooh. So the green seems to be cranked up. I'm having a hard time to get to 0. I disconnected that. There you go. Green. So let's see if I can make yellow. So that'll be green and red. There you have it. That's a yellow color. So I think I've done everything I plan to do with this tutorial. The code is really straightforward. The only new concept that we've already tackled a little bit is the PWM analog write, which allows us to write different levels of intensity to these LED pins. And if we were analog writing on the analog pins, these LEDs wouldn't work properly because PWM is a pulsing wave, and these LEDs just wouldn't work with a voltage that's like 1 volt. But if you give them a pulse of 5 volts that's on a fifth of a time, it's the same amount of power as if you're giving them 1 volt. But that pulse is going to work, which is what makes PWM necessary. So that's all for this tutorial. See you guys in the next one. Bye bye.